Hello. So, good evening to all of you. Welcome to the 12th live session of the NPTEL course Design of Reinforced Concrete Structures. I am Sanjay Kumawat, and today we will be discussing on the most important or one of the most important structural components which are present in a building. So, let's look at it. Where is my cursor? Okay. So the structural components which I am talking about is the staircase. So staircase are basically structural components which allows passage for the purpose of functionality between different stories of a building. And without wasting much time, I won't be taking up the classifications of staircase based upon their architectural looks and the various types of staircases based upon their types, but I would be taking up directly the classification of staircase based upon its support, because this is the classification which would help us to identify the type of design which we need to carry on depending upon the support conditions of a staircase. So staircases based upon their support types, they are basically classified into these two types. So let's first look at the first type. First type is the staircase, which is spanning transversely. So a staircase, if it spans transversely, first of all, let me explain you what does structure a structural component within a staircase it looks like. So in a staircase we basically have a slab, we call it as a waste slab, and this waste slab is followed up by a horizontal landing as I have drawn here. And again you have a landing at the top and the bottom if the staircase is a part of, if it lies in between two stories. If it is on a ground floor, then it is a different thing. So this is a staircase. A staircase, it consists of a waste slab. Okay, let me draw it properly. So this is the waste slab as you can see it here. So this waste slab would be inclined. This we call it as flight. This is the flight, whereas we call this as the landing, and this is also a landing. So landing are basically provided to give us rest. We cannot climb continuously, so to have some rest after every 14 to 15 steps we provide landing. So the various structural components in a staircase are the waste slab, and these two are the landings. So this waste slab we also call this as flight, and when we look this flight from top, and when I draw the projected view of this staircase, it will look something like this. So these two are the landing 1, landing 2, and the flight which I called it here, this flight in its projected view we call it as going. So this is the going. So what I was explaining, this structural component which is called as the waste slab, it can be supported in two ways. Either it can be supported on its transverse direction like this. So this would be a type of slab which falls under this category. And what is this? Staircase slab spanning transversely, because now the support to this slab, it is provided in the transverse direction. Now what can be the other type? The other type can be a staircase slab spanning longitudinally. So this is the longitudinal direction. This is the longitudinal direction and this is the transverse direction. So if it is supported transversely, then it is transversely supported staircase. And you must be wondering how can we support it longitudinally. So it is easy. What we can do, we can support it on either on a wall like this, or we can support it on a beam, like there can be a beam here like this beam would be extending through transversely. So we can provide, so if I draw the free body diagram, or not free body diagram, if I try to draw the support conditions, then longitudinally it would look like this. So it will be supported longitudinally. So let's look at it what my slides say further. So staircase slab spanning transversely. So these are some of the examples. So if my staircase, they are supported, it can be either supported on two walls as it can be seen here, or else it can be supported on two beams, or it can be supported on a wall and one beam. So if I look into its reinforcement detailing, so it will appear something like this. So as you can see, the slabs which are supported transversely, so this is the slab which is supported transversely. So this slab is supported on here and here. So as you can see, if I cut this like this would be the reinforcement detailing. So reinforcement detailing, in the reinforcement detailing I can see two types of steel rods. One is the dotted one, and the other one is like looking up like a stirrup. So can you tell me which one is the main reinforcement? Whether the dotted one is the main reinforcement, or the one which is looking like stirrup is the main, not stirrup, tie is the main reinforcement. Which one is the main reinforcement?
Bottom one.
Bottom one, the one which looks like tie. Yes. Why? Because my slab would be bending like this, so main reinforcement would be this one. This one. Okay, fine. That was understood, I think. Now let's look at the other type of staircase. So the other one being the slab supported longitudinally. So this I have already explained. So if you want to draw the line diagram of this staircase, so this would be like simply supported onto. While this, if you try to draw the line diagram, since the supports are only at the landing sites, so there will be support like this. So this type of line diagram, you must have solved some problems like this, beam problems like this in your lower standards, if you remember. So there is nothing too much difficult in this staircase design. So these were the two types based upon the supports. Now let's uh, go on to the design of this staircase. So, firstly, let me again come to the slides. The what important things we need in design is, firstly we need to know the effective length. So the effective length can be the center to center distance between the supports, and those supports can be either wall or beam. So that the first parameter we need to decide while designing a staircase is its effective length, and that effective length will be its projection like this, not like this length plus this length. Not, I'm not talking like that. We want the projection length. Projection means if I project it down, then the length which will come, that will be the effective length. So the first parameter we need is the L effective. The second parameter we need is the thickness. Thickness of what? Thickness of waste slab. So thickness of waste slab, it is again dependent upon L effective. How it is dependent, I will be showing you that in the further slides. Uh, so I will have effective length, I will have the thickness of the slab, and this thickness of the slab, then I need to calculate the load on the staircase. What load will be coming on the staircase? So let's look at it, how to calculate the load on the staircase. So first load will be the self weight of stair slab, that is self weight of the slab itself. Oh, what happened? So self weight of the slab means self weight of this, then self weight of steps. Self weight of steps means these are the steps. Then self weight of finish, I will like put some finishing tiles on this or something like that. So I need to also have the self weight of finish. So all of this would give me the self weight of dead load of my slab due to self weight. Now, coming towards the fourth point, which this is four, what does it says? The imposed loads are assumed to act as uniformly distributed load. So this was about the dead load, but when we talk about the imposed load, so the imposed load, it is assumed to be acting uniformly on a horizontal projection. So while designing, we have to consider the load which is acting on the horizontal projection like this. So whatever load it is coming on this inclined slab, I need to convert it into horizontal projection. Okay, how we will convert it, we will be looking at it in some time. So this was about the staircase load. So what did I say you? I said you we have to look for L effective, we have to look for thickness of slab, and third one is based upon the load, dead load and live load, we will be calculating the maximum moment on this staircase, and based upon that maximum moment I will give the reinforcement detailing. Again the reinforcement detailing will come at the bottom like this, and then it will expand into the top of my slab like this, and the one which comes here will go like this down. So this detailing also I will be showing you in the further slides. Okay, so let's look at this problem. Design the staircase slab shown below. Where is it? Okay. So the stairs are simply supported on beams provided at the first riser and at the edge. So we have a beam. So this staircase it is supported on the beam which is at the riser level and at the edge of the upper landing. So this is the other beam on which my staircase is supported. The staircase has a finished load of zero point 0.8 kilonewton per meter square, okay, and a live load of this. So both of this finish load and the staircase load they are given on the projection level. That is, they are already converted and given us on the projection level. Use M20 concrete and Fe415 steel. Assume 20 mm clear cover and 12 mm diameter bar for longitudinal reinforcement. Okay. So let's begin with this problem. Firstly, what I said, what I need to calculate the effective span, that is LE. So LE is the center to center distance between these two beams on which my staircase is supported. So just try to see what is it. So as you can see it here, from here to here I have 3 meter, and then from this point again to the external point it is 1.5 meter, and this is 3 meter. So I need to include this part, center part, so it will be 3 plus, or I should take it in better, 3000 plus 150, and then it is 1500 the landing, and the landing length it is extended up to the exterior point of my beam. So I need to again subtract 150. So 150 will get cancelled, and my L effective will be what, 4.5 meter. So that was understandable. Let's see. So effective span is directly I have written it here, 4.5 meter. Then what I need to calculate is the thickness of this slab. So this thickness of this slab, it is again based upon some approximate values, design values. So those approximate values, the way we used to design in slabs, we would have some approximate values, LE by D. So here also for we have two cases. So these are not mentioned in any code, but these are approximate values. uh, Based upon the experience you can like directly take up some depth based upon if the staircase is supported simply, then I need to take LE by 20 as the D value, and if it is a continuous then I need to take LE by 25. So our case is of simply supported type, so I will take it as LE by 20. So the depth which I am supposed to take is 225 mm. Then this 225 mm I will round it off to 230 mm, and then I will calculate the effective depth. This is the total depth D, and the effective depth it can be calculated easily by subtracting it with the nominal cover which is given in the question, 20 mm, and then uh, bar diameter is also given 12 mm. So after subtracting this, that is 230 minus 20, 210, minus half of this dia to 204. So that is the effective depth of my slab. And what else we have here is, what else we have, okay, now let's move on to the determination of load on projected plan area. So we have the live load and the finished load, but we need to calculate the dead load. So dead load would be what, it would be simply calculated based upon the depth of this slab. So 25 kilonewton per meter square is the density of concrete. I will multiply it with the height and keep my dead load into the units of kilonewton per meter square, and I will assume some depth of this riser and some approximate value. You should be able to assume it. I have not given the values which are commonly used, but you should be able to know. So 150 I'm taking it as this, and this is the riser, and this is what, this is the thread. So here what I have done, I have calculated firstly the dead weight of slab. So how I am projecting the dead weight of slab, because 230 is the depth of this slab which is inclined like this, 230. So I need to take this on the projected area. So to take this on the projected area, I will have to calculate this vertical thickness of the slab. So this vertical thickness of the slab would be based upon the ratio of the projected area. So originally what we have, originally I have, suppose I am taking this the thread of 300 mm and a riser of 150 mm. So based upon this, since I have calculated the depth as 230 mm, now I have to convert this to a projected area. So I have a horizontal, like for example, just a minute. This is the thread and this is the riser. So the riser is of 150 mm and my thread is of 300 mm. So corresponding to this thread, I will have a inclined surface like this. So this inclined surface has to be converted. So for this 300 mm I have this projection. So this can be easily calculated by Pythagoras theorem. So you will get it as 335.4. Now I have to calculate an equivalent weight of this 335 length in the form of this horizontal length. So like I have to accommodate this inclined length into this horizontal length. That would be my projection. So I will simply take the ratio 300. So this ratio would what give me, it will give me the fraction by which this inclined length can be converted to this horizontal, because this corresponding to this inclined length I will have a projection of 300 mm. So the load of this 335 has to be converted into this 300 mm. So this can be converted by using this fraction. I think you would be getting this. It is not very hard. So I have taken this fraction, and 25 is the unit weight and this is the inclined thickness. So I am getting this as the dead weight of the waste slab in terms of kilonewton per meter square. Now what I need to calculate is the dead weight of the steps. Dead weight of the steps can again be like, this is the step and the thickness of this step is 150, but this step is not uniform, it does not have a uniform depth throughout. So I'm taking the average by dividing it by half. So the average depth would be 0.15 by 2, and when I multiply it by 25, that is the unit weight of concrete, I will get 1.88 as the dead weight of the step. So I have the dead weight of waste slab and the dead weight of the step. Now further, what I will simply add up all the dead weights. So this is the dead weight due to the waste slab. This is due to the waste slab, this is due to the step, and this is due to the finishing. They have already given me it on the incline, on the projected area, so I can directly add it up. So what were all the values were 1.88 plus 6.4 plus zero point 0.8, I will get it as 9.11. Now I have to use factored load, so I multiplied it by 1.5. So this was all about the dead load of landing. Sorry, dead weight of what, waste slab. Now I need to calculate the dead weight of landing. So here I don't have landing in the question, only the landing which I have is this one. So the difference between this and this would be, it has, I have projected the weight of this waste slab into a horizontal projection, but here this is already horizontal, so I will directly get the weight for this. Okay, so let's look at it. This part is not difficult. I have directly multiplied 0.23 with 25 because it is already horizontal. Now I added it up with the finished load, and then I got the total dead load as 6.55. So now what I have, what simplified acceptable I have for my staircase is, I have every dead load on a projected area. So suppose this was the projected area of waste slab, and this is for landing. So this is 6.55 and this is 21 point, oh sorry, I have not factored it yet. So this is 17.33, 17.3, and this is 21.2. So we have two different types of UDL, and my staircase is simply supported. So this was what I was drawing, and my staircase is simply supported. Now what I have to do, see, I have already determined the L effective, I have the thickness. Now what I need to do is, I finally need to find the reinforcement. The reinforcement will be in correspondence to the flexural strength of my staircase. So I can easily calculate the maximum bending moment based upon this load diagram. So this is the load diagram. I think you all can calculate R1 and R2. You can calculate it. So what I am doing, what it is written here is I am taking this design for corresponding to 1 meter width. So I have taken a 1 meter strip like this, the way we used to do in slabs. So based upon that, if I solve this, I will get R1 has 47 and R2 has 44. And based upon your previous knowledge on how to calculate the maximum bending moment on a simply supported beam, you can also calculate the maximum bending moment and the location where it is occurring. So I have already done it for you. You all can try it. It will come exactly at 2.23, and the maximum bending moment is 52.53. Now, now what I need to do based upon this bending moment, now it is very easy. The way we used to do for slabs and beams, I will calculate R, which is mu by BD square, and based upon this R value, I will calculate the percentage of steel, and this percentage of steel I will convert it into area of steel, and those area of steel I will convert it into bars. So I need to have 12 bars which are at 140 center to center distance. So the percentage of steel which I have provided is 0.4%. And finally, I will also provide the distribution steel, which is 0.12% of the cross section area of my staircase. So this is the final detailing of my slab, so it is not very difficult, as you know. So one more thing I need to highlight is the main reinforcement. It will like go at the top into the landing, and the main reinforcement of the landing, it will go at the top into the waste slab. Why this is happening? Because we need to take care of any negative moment which is occurring at these junctions. So these junctions are very sensitive to negative bending moment, and that is the reason we extend the bars into the negative side of landing and into the negative side of the waste slab. So this was all about the design of staircase I wanted to discuss in today's class. Now, if you have any doubt on this problem, then please ask me. You can look for more complex problems also, but this was all of the problems are based upon this design methodology only. So I think there is no doubt. So I will proceed to my further uh, what I have with me. So in the previous class, you all requested me to discuss the detailings in column. So I have brought it here. So let's first look at the transverse reinforcement detailing in the column. So what is transverse reinforcement detailing? It is the lateral ties which we provided so that the so that the tension which is coming into the longitudinal bars, those tension forces, it can be like nullified, or in easier way I should say, my column longitudinal bars, those get confined because of the transverse reinforcement. So these transverse reinforcements are very important. So what my first point says transverse reinforcement is provided in the form of rectangular or polygonal links, you all know it, with an internal angles less than 135 degree, or by circular rings which are capable of resisting circumferential tension. So circumferential tension means if I have this cross section and these are the bars, so these bars, like because of top compression load on this column, because of this top compression load, what will happen, these bars will try to bulge, or buckling effect will happen. Not buckling is not the right term, but what will happen, these bars will be subjected to tension, and because of this tension, what will happen, these bars will get outside. So in order to avoid that effect, I will confine the them with the help of what, transverse reinforcement. So that is what my point one is trying to say. And regarding the hooks, so if my four bars are this, and if I provide this, then the hoop which I provide, this hoop, it should not be greater than, so so again let me draw it. Okay, so if I try to draw the transverse reinforcement, this would be my transverse reinforcement like this. So one can like finish it up to this point only, point to point, like end, start to end. I have to end it like this. Now I need to also provide the hooks, because this type of reinforcement detailing won't help my longitudinal bars in sustaining the circumferential tension. So I will now provide hook. So this hook, like, I'm extending it, please see it. So I will extend it like this, like it won't go above this point, but just for your understanding. Now I will provide a hook. So this is 90-degree hook. If I bend it further, I'm sorry, this will be what, 135-degree hook. So point one stays, point one says we cannot provide a hook which is more than 9, which is more than 135-degree. Okay. And 135-degree would be somewhere here, and we can also have 180-degree like this. So my reference point is what? My reference point is this. This is 90-degree. This is 135-degree. This is 180-degree. So like that, the hooks are provided. So next 2 points are based upon the hooks. What they says, if my hook is bended by 90-degree, then I need to extend the bar not less than 8 times the diameter of bar. It should be extended at least 8 times the diameter of bar. And when my hook is of 135-degree, I need to extend it not less than 6 times the diameter of bars. And when it is 180-degree, then I cannot extend, then I cannot keep the extension of my bar less than 4 times. So this makes sense. How? So if I have these 4 bars, and if I have this transverse reinforcement, and if I provide only the, so this is my reference line. So if I only provide the 90-degree bend like this, then this 90-degree bend, it should have length of 8 phi. Why? Because this 90-degree bend would not be as safe as the bend which would be of 135-degree. So that is the reason this length, if I, this length which is needed is less than this length, this is 6 phi. And more safer than this hook would be a bend of 180-degree. So that is the reason I can reduce the length of this 180-degree hook even lesser, 4 5. So this was easy to understand. Now let's move on to, I hope this diagram was clear. So pitch and diameter of lateral ties, I have discussed this in previous class. Okay, let's, we can again. So pitch, what is pitch? Pitch is nothing but the uh, spacing between two ties. So if this is my column, and if this is my stirrup, then the spacing between these two stirrups, not stirrups here, ties, then the spacing between these two ties is nothing but the pitch. Okay. So you all know, we there is no need of designing the pitch. Based upon these clauses, we can decide the spacing between this pitch and the diameter, spacing between these two lateral ties, which we call it as pitch, and the diameter of this lateral ties, they are also decided based upon these codal provisions. So there is no specific design for this lateral ties, only we need to follow the codal provisions for maintaining the pitch and for the diameter of the lateral. So here you can see the pitch or the spacing, it should be less of this three. That is, it can either be least lateral dimension, or it can be 16 times the smaller diameter of the longitudinal bar, or it can be 300. So a lesser of these three values would be the spacing between the lateral ties. Now the second point is based upon the diameter. So diameter point is, diameter of lateral ties cannot be less than 1/4 of the diameter of the larger longitudinal bar, and in no case it should not be, it should be less than 6 mm. If the longitudinal bars are spaced less than 75 mm on either side, then the transverse reinforcement need only to go around the corners. This I would be explaining you with the help of a diagram. So what does this clause says? These are the longitudinal bars. These are all the longitudinal bars. So if this, the spacing between these longitudinal bars, if it is less than 75, then I can like directly take my bars, my lateral ties from corner to corner. So this would be more making sense in my diagram number 2. So diagram number 2, it has more numbers of longitudinal bars. So if the spacing between these two bars, it is less than 75 mm, So I can directly take this lateral ties from corner to corner, like no need to provide stirrup in between this is no need of providing this, because the spacing between two longitudinal bars is less than 75. So the third case is also similar to second case, only the difference is we have lateral ties in the other direction. We have longitudinal bars, extra longitudinal bars in the other direction also. Now, now let's look at the case 4 and 5 and 6. So here you can see in case 4, 5, 6. Now the distance between the two bars it is greater than 75. So when the distance between the two bars is greater than 75, so I need to provide this extra open ties, as you can see it here, or those ties can be provided in this form, or they can be provided in this close lateral tie form. So this was about the distance between these two bars. Now what my next clause says, next clause says that in no case the unsupported length between this unsupported length of my transverse reinforcement it can be greater than 300. So this is the unsupported, what in the previous clause what we have seen that this distance, if this distance exceeds 75, if this distance exceeds 75 and if we have a bar in between them, then we need to provide a lateral tie. Now what does this clause says, this clause says this distance, yes, please mute yourself. uh, Prasada Rao, please mute yourself. I cannot mute you actually. I can mute you, okay. So what was I saying? The previous clause says if this distance exceeds 75, then I need to provide a open tie in between them if there is a presence of longitudinal bar. But if there is no longitudinal bar, in that case also the center to center distance between these two bars it cannot exceed 300. And this is true for any shape of my structural component, whether it is L, T, or plus minus shaped columns. Okay. Now coming to the other clause. Now what does this clause says? If the longitudinal reinforcement placed at a distance less than 48 times the diameter of the tie are effectively tied in two direction, additional longitudinal bars in between these bars need to be tied in one direction by open ties. Okay. So now what does this clause says? This clause says me, suppose I have, now it is difficult to understand the difference between the previous clause and this clause. What does it is saying? The previous clause it was trying to say me the unsupported length between these two it should not be greater than, in no case it should be greater than 300 mm. So the unsupported length of this tie it cannot be greater than 300 mm. Now what does this clause says? This clause says me if this distance between these two ties, if it is less than 48, if it is less than 48 phi, that is the diameter of the tie itself, if it is less than the 48 tie, and if we have some intermediate longitudinal bars also, if this intermediate, suppose this distance is greater than 75, again we need to like take care of all the clauses, then only we can verify it. Now suppose if this distance between the two adjacent longitudinal bars is greater than 75, so now we need to take this, we need to take care that why he is unmuted I don't know. Okay, so what I was saying, suppose the distance between the two corner bars it is less than 48 phi, that I agree. Now again you need to check one more condition, what the distance between the two consecutive bars it is greater than 75. If it is greater than 75, then what we have studied in the previous class, we need to have stirrups in the inner bars also. So now what does this clause says? This clause says okay, if the distance between the exterior bars if it is less than 48 bar, then you need to provide open ties. Like there is no need to provide a closed tie. I can also provide a tie like this, but there is no need of providing this type of tie. If the distance is less than 45, you can directly provide an open tie like this. Okay, now moving on further.
Sir, so here, it should be greater than 75, not less than 75, na?
See, if it is less than 75, suppose, let's take another example. Suppose this distance is less than 75, okay? And this distance is obvious, this distance would be obviously greater than 75. So, according to clause 1, I don't need to provide any lateral tie for these two bars. It can directly go like this, and I can provide a stirrup like this. Okay, but if this distance is greater than 75, then I will have to provide bars here also like this. And now this clause, the 48d wala clause, it is again mentioning one more condition. What it is, that condition is, it is mentioning, look at the exterior bars. If these are the exterior bars, and if the distance between these two exterior bars, if it is less than 48, then that is for sure कि I have to provide ties for the inner bars, but those ties you can provide it as open ties. There is no need to provide closed ties. Was it clear?
Yes, sir.
Okay. So you have to compare all of these cases, then only it will make sense, because by reading them it seems like all of the clauses are not making any sense. Okay, fine. Now let's move on to other clause. Now what does this clause says? When longitudinal reinforcement is placed in more than one row, so here we have four rows. Okay, so the longitudinal reinforcement in row is assumed to have effective lateral strength only if the transverse reinforcement is provided for outermost bar. So what is it saying? So if I provide this extra stirrup for this inner bar, then if suppose if I have this length and a bar located here nearby, so what will happen? Both of this bar will experience some circumferential force, and because of this circumferential force might this tie won't be very effective. Okay, so to make sure that my tie is effective for the inner bars, what I need to take care is the distance between these two bars, it should be at least 3 5, and this is for this tie also. So this tie, and one more will be what? Okay, we have these ties only. Here I don't have any tie. Okay, okay, I have here, these are the two bars. So for this tie to be effective, for this tie to be effective, I need to take care that the position of bar 1 and 2, it should be greater than 3, because if it is less than 3d, what will happen? The combined effect of that tensile force will be more, and my lateral support would not be very effective. And now if I come to this two bar, the bar 2 and bar 3, so I have bar 1 and bar 2, and the other would be a combination bar 2 and 3. So 2 and 3, now this stirrup I have to see. So for this stirrup I need to see this distance, this one. Okay, now this is again a clause. So if because of a huge load I have a huge cross section and the number of longitudinal reinforcement is very high, then in that case what I can do, I can group the longitudinal reinforcement, and those group would be,
Sir, in the previous case, if it is less than 3.5, then we have to provide extra ties.
if it is less than 3, no, why we have to provide extra ties? We have to
You
make
said,
sure it should not be less than 3 3d.
okay,
Okay,
okay.
if it is see, again the clause 1 says if it is very close, then it will be like less than 75. You get me? So
Yes, sir.
we need to take care, if it is less than 75, but it should not be less than 3d, so that you should take care of. Now here we can group, if the number of longitudinal reinforcement is very high, I can group my bars like this. So you can read this and understand. Longitudinal bars may also be grouped at each corner, and each group is adequately tied together with transverse reinforcement. So here you can see each group is having a transverse reinforcement of its own. So in such a case, transverse reinforcement for a column as a whole may be provided on an assumption that each group is a single longitudinal bar. So I can assume this group as one bar. So I have a total of four bars. So now these four bars will have a big transverse reinforcement like this, and the basis of this big transverse reinforcement would be based upon the assumption that my each group is acting as a single bar. So this was not difficult clause. So I think these were all the clauses which I wanted to discuss for, or I wanted to make clear for the transverse reinforcement for columns. So that was all about today's lecture. So today we discussed about design of staircase. We look for the different types of staircases based upon its support conditions. And one more thing, I have not covered the problem for staircase which is supported transversely. You can look at it in any other book. The only difference between the two cases would be today we have designed a staircase which was of this type, but the other one would be of this type. Now my slab would be supported like this, so that you can like explore. I will leave it to you. You can do it by your own. Now now the floor is open for you all. If you have any question or any query, I would be happy to answer. Any question?
Sir, can you tell about what is your PhD subject?
Oh, I'm like working on earthquake engineering. Basically, I'm working on base isolation system, innovative base isolation systems. So they are called as seismic metamaterial. So basically, I'm working on foundations for earthquake resisting forces. So those foundations are made up of metamaterials.
Sir, are you from which IIT?
I'm from IIT Bombay. On on every slide, I used to mention it.
Okay, sir.
See, okay. Mithilesh, you are not audible.
Oh, hello.
Yes, yes. Come again.
Audible?
No, no. Shivam, can you hear him?
No, sir.
Mithilesh, I suggest you to rejoin if possible. Or you can type your query in the chat box if you wish to. Sir, how should we prepare for GATE exam? Oh, GATE exam. Like, GATE exam is a very good practice. Why I am saying it is a good practice, because you will be studying all of your engineering courses all at once. So you will be having all your concepts in your mind. So how to practice it, for that all depends on you only. What I will suggest you is, GATE exam is a competitive exam and you can crack it very easily. Like, cracking the GATE exam, it is not a big deal, but to score for it is a big task. And since it is a competitive exam, you need to build up more speed. For more speed, you should be giving more number of test series. So just join some test series, like I can name you some test series, Made Easy or some IES Masters. Join, solve more number of problems. And one more thing, make your subjects, make one or two of your subjects very good. Like, I like structural engineering. I'm not saying you like I remember everything, but when I read structural engineering subjects, I can understand it, I can feel it, because I have cleared my concepts from very initial stages. So just make sure you have one or two subject basics very good, whether it is geotechnical or it is structures or it is fluid dynamics or it is environment. You have 3 to 4 branches: geotechnical, environment, fluid mechanics, structures. So make some of this, and apart from this, you should have good hold on maths and your aptitude. I strongly recommend never to lose your marks on maths and aptitude, because those are like all in your hand. If you wish to like study further, you should have a strong aptitude, because most of the gate questions for most of the subjects, environment, geotechnical, some of the questions are mostly based upon aptitude. You can easily play up with the units and bring out the answers. So more practice and practice will make you more perfect and will make you score good in gate exams. That's what I would suggest you. And since it is a competitive exam, I recommend you to. I don't think you must have not joined some classes. If you join some class, that would be more. helpful. I'm not saying you cannot do it on your own, but looking at the competition, it is good you have some support from outside, and that support is nothing but like joining some good class. Anything?
Okay, sir.
Okay,
Yes, sir. Yes, sir.
so you can crack it and like join some IIT and do research, that I will recommend. Okay, so any more doubts?